Okay, today we're going to be learning 7.1, which is on page 203 in your book. Go ahead and turn there. And we're going to be using what we've learned from chapter 6 to help us solve inequalities. It's very similar. There's a couple things that are going to change, but we're still going to be solving for x eventually, but we have a couple of activities in order to get us there first, okay? So the first activity is an explore activity, and it wants you to investigate inequalities. And it says whenever you perform any of the four basic operations on both sides of an equation, the resulting equation is still true. So if I do something to one side, I do it to the other, which means that my equation is still balanced, right? Both sides are still the same. So if I add 2 to the right side of the equation and I add 2 to the left side of the equation, everything is still balanced. So that's why we do whatever we do to one side, we have to do to the other. And so we're going to explore what does doing something to both sides of an inequality, what does that do to it? Are we able to do that? Is it still true if I do whatever I do to one side, I do to the other side? Is it still true? So let's look at this. Looking at this problem right here, it says at the table here, it says 2 is greater than or equal to -3. That symbol in there right here shows greater than or equal to -3. According to this explore activity, what we need to do is add 3 to both sides. So if I have 2 is greater than or equal to -3, and I add 3 to this side, I end with 5. And it's greater than or equal to, I keep the same sign. If I add 3 to -3, I end up with 0. And let's see if this is still true. Is 5 greater than or equal to 0? Yes, it's still true. We know that it's not equal to it, but in this case, 5 is still greater than or equal to. It's a choice between the two. It's not and equal to, but in this case, it is true. So this would be written in here. I'm just writing it a little bigger for you. And is our new inequality true or false? It is true. So I'm going to erase that for you, and let's work on the next problem to see if the pattern still continues. So now they give us -1 is less than or equal to 6. And they want us to add -1 to both sides. So if I add -1 to -1, I end up with -2. And is that less than or equal to 5? If I do sub 6 minus 1, I end up with 5. And let's see if this is true. -2 is less than or equal to 5. Yep, -2 is less than it. So that is also true. Right? Go ahead and solve the third one on your own. Tell us if it's true or not, and then I'll work through it with you. All right, -8 is greater than -10. They want us to add -8, so -8 plus -8 equals -16, and that is greater than -10 plus -8 is -18, and so this one's a tricky one sometimes because I'm saying -16 is greater than -18. Well, if I do a number line and I'm right here is 0 and this is -16 and this is -18, well, yeah, -16 is closer to 0. It's closer to the right. Remember, all numbers to the right are bigger. And so -16 is larger or greater than -18, so this is also true. So we can make a conjecture. A conjecture is just kind of a rule. What rule can we make? When you add the same number to both sides of an inequality, is the inequality still true? Yeah, we know that because everything we just did, no matter whether one was positive, one was negative, or one was negative and the other was positive, or both of them were negative, then they still remained true. So let's see if we can check this problem out by looking at subtracting inequalities from it. Okay, so let's erase all of our work over here. And you tell me, does it work for subtracting things? Yeah, it does. Because weren't adding, isn't it the same thing as plus a negative 1? Isn't that the same thing as subtracting a 1? Yeah. Or subtracting 8 is the same thing as adding a negative 8 because we add the opposite. These two are the same thing. So it doesn't matter if you're adding or subtracting inequalities. They will always be the same on both sides. Okay? So let's move on to the next type of problem. It's at the bottom. And this time they want us to do something different. They want us to divide, okay? So we've got 4 is less than 8. And they want us to divide by 4. So 4 divided by 4 equals 1. And 8 divided by 4 is 2. So let's see if that's true. 4 divided by 4 is 1. That's still less than 2. So my new inequality, this would be written in here, that it would be 1. I'm sorry, this guy would be written in here. This is our new inequality, and it is still true, right? 1 is less than 2. Okay, so let's move on to the next one, and it says, this is true, and it was 1 is less than 2. And then the next one is 12 is greater than or equal to negative 15. And I've got to divide by 3. So if I divide 12 by 3, I end up with 4, and it's greater than or equal to negative 15 divided by 3, which would equal negative 5, and 4 is still greater than or equal to negative 5. So you'd put this information in this block here, and it's still true. Following along with that? Let's talk about the next one, though. Let's do this one. Let's do negative 16 is less than or equal to 12. Let's divide by negative 4. Divide by negative 4. And since I have a negative divided by a negative, I'm going to end up with a positive, correct? And so I end up with positive 4 is less than or equal to, let's see, and I end up with a 3. That didn't work, did it? Because 4 is not less than 3. This is not true. 4 is greater than 3. Let's see. So this is false right here. And down here, let's double check this one. 15 is greater than 5, and we've got to divide by a negative 5. And we divide by a negative 5 over here, and let's see what it ends up to be. So since it's a positive divided by a negative over here, I end up with negative 3 is greater than, and this should have been divided by negative 5. It's going to be a negative again, right? Negative 1. And we know that according to our number line, if we have a 0 here, a negative 1 here, and a negative 3 here, that negative 3 is actually smaller than negative 1 because anything that's to the left is smaller than anything to the right in a number line. And so this is false as well. And so there's something that you should notice when you divide both sides of an inequality by the same negative number. It has to be the same negative number because if not, then it would be different. But do you notice that it's not true anymore? So we've got to think about what could we do to make this true. Since this is false, what would we do to make this inequality true? We would have to say that negative 3 is actually less than negative 1, and so we would have to reverse the inequality sign. Okay, so looking at the next page up here, what would you do to make the inequalities that are not true into true statements? You would just simply flip the inequality. So take notes, do whatever you need to do, but when you divide both sides of an inequality, I'm sorry, it's kind of messy. I'm using my finger because I don't have my my stylus. By the same number, same negative number, you must you must reverse, let's say, must reverse the inequality sign. Okay, I know that just erased it, so go ahead back if you need to. I don't know how that ended up erasing. Maybe I just changed the next page. Oh, there it is. The inequality sign. I think I just hit the arrow at the bottom. You have to flip or reverse the inequality sign. That is only when you are dividing both sides of the inequality by a negative number, okay? By the same negative number. That's when you reverse the inequality, okay? So, how do you know that this holds for multiplying both sides of an inequality or by a negative number? Look at this. Communicate mathematical ideas for this number 3 right here. Explain how you know that your conjecture holds for multiplying both sides of an inequality by a negative number. Go ahead and think about that for a second. How do we know that it doesn't just work for dividing by a negative number, it also works for multiplying by a negative number? Let's try that out on the side, okay? So let's prove that. Let's say that we had to multiply both sides of an equation. Let's use that last one that we just did. We did, it was 15 is greater than 5, which is true. Let's say that we're going to multiply by a negative 5, okay? And so we end up with 15 times a negative 5, which is negative 75, is greater than 5 times a negative 5, which is negative 25. Well, this can be a little bit confusing because we're talking about negative numbers, so I really want to sketch a really quick number line here, and I know that my 0 is here, and my negative 25 would be here, my negative 75 is over here, and I know that anything to the left is smaller, and anything to the right is larger or greater. And this is saying that 75 is greater than negative 25, and we know that's not true because it's to the left of it. So this is not true. So in order to make it true, I have to reverse my my inequality symbol. So the true statement would be negative 75 is less than negative 25. So we know that when you are multiplying, I should change what we just wrote to when you're multiplying or dividing by both sides of an inequality by a negative number, only when it's by a negative number, because when we did the other page over here, remember these guys were true. When we multiplied by a positive number or divided by a positive number, then that was true. But when we're dividing or multiplying by a negative number, then we have to switch the inequality symbol. Okay? That happens because multiplication and division are so related to each other. Multiplying a number by the same is the same as dividing by its reciprocal, right? So when we multiply by 1/2, it's the same thing, or divide by 1/2, it's the same thing as multiplying by 2/1. Remember how you don't divide, we multiply by the reciprocal when we do fractions and everything. The same thing's true. It's the same. They're so related to each other. So change your notes to say when you multiply or divide by a negative number when you're using inequalities, then you have to change the inequality symbol to make it true. Okay? All right. Coming down here for example 1, take a look at it. It says solve in each inequality and graph the solution. So it's x plus 5 is less than negative 12. My goal is still to figure out what x is. That's still my goal. And just like when we had chapter 6, when we were trying to find out what x equals, we have to undo everything to find out, to get the x by itself on one side of the inequality. And so in order to do that, I have to get rid of the 5. How do I have to get rid of the 5? I have to subtract 5 because it was a positive 5, so I have to do the opposite. Whatever I do to one side, I have to do to the other. And so I'm left over here with x. These two cancel out, right? I still keep my inequality symbol. And over here, I have negative 12 minus 5, which is the same thing as adding the opposite. And so I end up with negative 17. And so x is less than negative 17. Now graphing this. I don't remember if you did this in 6th grade or not, but there's a couple different things I need to teach you about graphing inequalities. If you look down here down the bottom, I don't know if I can zoom in on it or not. Let me see if I can. Yes, I can. Okay, so if I look down here at the graph, notice that they gave us a number line that started at negative 10, went all the way down to negative 17 and beyond into negative 20, right? And so I know that I have to think about all the numbers. This is really tricky, so pay close attention to it. All of the numbers that x could be a lot of different numbers. And x can be anything that's less than negative 17. So it can be negative 18, because that's smaller than it, negative 19. It can be negative 100. It can be every number that's smaller than negative 17. So any number to the left of it. It can't be negative 17, though, because we don't have that equal sign under it, too. Does that make sense? We just have the less than sign there, okay? And so there's two different ways that you do this. First of all, we're going to go to the number 17 on the graph right here. But I want you to pay close attention. That circle you put on the number 17 and you keep it as an open circle. There's a little hole in it, so you kind of draw the circle like that. And the reason why is that shows that negative 17 is not included in our answer. An open circle means that it does not include negative 17. Okay? So an open circle means it does not include the number that it's on. Sorry, I keep on hitting the arrow. But it does not include the negative, oh, I did it again. It does not include the negative 17. So if you look really closely here, there's an open circle on the 17, and then the arrow, you draw a line with an arrow going to the left, with an arrow keep on going. And the reason why is it's showing that x could be an infinite number of answers starting at negative 17, and to the left, every number is included in it. Okay, so you need to know it's open circle and an arrow to the left because it's every number can be that x number. Okay, so let's go on here. Check the solution. Describe. This is how you check your work. You know how sometimes we substituted in something from before when it was an equal sign in here? This time we can check our solution here by saying, okay, check the solution, substitute in a solution from the shaded part of your number line. That just means pick any number in here. Negative 20 is included in that arrow. Make sense? And so we can say negative 20, is it less than negative 17? Like, is it less than that? Yes, it is. Negative 20 is less than negative 17, so this inequality is true. Does that make sense? Okay. Let's move on to the next page, and let's give you another one. Here's a second example. 8 is less than or equal to y minus 3. Now our goal for this problem is to find out what y equals. So we've got to get it by itself. How do we get that y by itself? Just like our other problems, we need to add 3 in order to get rid of this part. Whatever we do to one side, we have to do to the other. So I'm going to add 3 over here, and I end up with 8, 9, 10, 11. 11 is less than or equal to y. This problem is different now, isn't it? That means that I have the equal to sign in it. So if I zoom in over here, you're going to see that the circle at the 11 is shaded in this time. Notice how it's a closed circle and it looks like this. The last one was open. This time it's colored in. That means that my answer is going to include 11. So 11 could be the answer. So there's a big difference between an open dot and a closed circle, or open circle, closed circle for when I'm doing a graphing my inequality. Okay, that will count on your test. That it does make a difference. That if it's open, closed, or closed circle. If you have an inequality that has that equal sign down the bottom, that means closed, and this means closed. I'm trying to fill it in all the way with my finger, but both of these means closed. Closed circles whenever you fill them in. This would be an open circle, and this would be an open circle. Notice the differences. This one has the equal sign down the bottom. The ones over here have an equal sign down the bottom, and these ones do not, so it's an open circle. Make sense? Okay. So take notes on that if you need to, but I'm left with this inequality. Is 11 is less than or equal to y. So think before you even graph it. My suggestion to you is to think of answers that y could be. Just start making a little bit of a list. Could y be 11? Yes. So let's write that down. Could y be 12? Yes, because y is greater than 11, so 12 is included. Could y be 13? Yes, because it's greater than 11. Could y be 10? No, because it does not. 10 is not greater than 11, right? And so these help me if I think about it that way. Then when I graph on my number line, then I know that it includes 11. So 11 is going to have a closed dot, right? And I know that I have to be going in the direction of 12 and 13 because I thought of numbers that y could be first. That is your biggest suggestion that I can give you for this, is to think to yourself, what could y be? Start with the number that's given over here and say, could it be 11? Yes, because I have that equal sign there. And then check the one below it and the ones above it to see which direction your arrow is going to go when you create your inequality. A couple things that you need to know is that when you're graphing your inequality, notice that it's right here on the line. It is on top of the actual number line. The open dot, closed dot does matter, like I said, and you do have an arrow showing that it includes all numbers because it's infinite. It doesn't have an ending. We will have problems that do have an ending to it at some point, but we're not there right now, okay? And so, make sure you ask any questions if you have that, and we can go on to the next one, okay? Oh, how we could check it? We could substitute something in. So, just like the answer over here, it says you can plug it in and say, okay, we thought 8 is less than or equal to 12, because that's one of the numbers on the number line, minus 3, we plug that in, and so we say 8, is it less than or equal to 12 minus 3, which is 9, and yes, 8 is less than or equal to 9, and so this is correct. So you just plug a number in there that is included in your number line for your marked area. Okay? I'm going to erase that really quick, and let's move on to the bottom one. You try these problems on your own first, and then follow along with the video, okay? It says down here, solve each inequality. And so, let me see if I can get it bigger, and let's talk through it, okay? In order to get the y by itself, think about what you have to do. You're going to add 5 to both sides because it's being subtracted right now. And so in order to get rid of this 5, it was a negative. I have to add 5 to both sides. And looking at these two, it's going to be a negative number because that's the greater absolute value. And I'm at negative 2 when I add those two together. And so I'm left with y is greater than or equal to negative 2. So I've got to ask myself a question. This is how I want you to go about it. I want you to say, can y be negative 2? Yes, it can be because of this equal sign in here. Okay, that's what means it can be -2. So I'm going to have a closed dot for my answer as soon as I include that -2, right? And now I've got to find out what direction it goes. Can y be -3? If y is greater than -2, that means that y has to be bigger than -2, which means it's to the right of -2, and -3 is to the left of -2, so it cannot be -3. Does that make sense? But a number that is bigger than -2 would be to the right of it, and that would be -1 and 0 and 1. Does that make sense? So when I make my graph right here, I'm going to put a closed dot on -2, and then I need to include -1 and all those numbers to the right because it's going to be bigger than -2 and include -2. And so my arrow goes in that direction. Does that make sense? So closed dot because it includes the equal sign, and then I'm going to the right because every number has to be, the y has to be bigger than the -2. Okay? Looking at the next one, go ahead and try to solve it on your own, and then pause the video if you need to, and I'll explain it right now, okay? So 21 is greater than 12 plus x. I've got to get rid of the x, or get the x by itself, I'm sorry. And so how do I undo that part of the problem? I have to subtract 12 from both sides. And so if I have 21 minus 12, then I'm left with 9. And so 9 is greater than x is what I'm left with, right? And so do I have an open circle or a closed circle this time? This time I'm going to have an open circle because there's no equal sign with this, okay? It's just a greater than sign. And so I know that 9 is greater than x. So if 9 is greater than x, can x be 9? No, because it doesn't include it. Can x be 10? No, because 9 is greater than x, and so x has to be smaller than 9, so that means that x could be 8 or 7. Does that make sense? It could be 8 or 7, something like that. So that means that I'm going to put an open circle on the 9, okay? Open circle on the 9, and I know that I have to go in the direction of the 8, 7, 6, like that direction, because all the numbers are going to be less than it. Does that make sense? So open circle, and I'm going this direction, and I figure that out by determining what could x be, okay? And then I can plug in any one of these numbers in here that's not these ones over here, but I can plug in all these other numbers. I can plug in 0, 1, 2, 3, -1, -2, -3, and plug those in to see if those work. So if I do, go back to my problem, and let's say I plug in a 1 for the x, and it says 21 is greater than 12 plus 1. I just picked 1 because it was within my line in here. Does that make sense? And so I could pick any number. It's just easy to add 1. And so I ask myself, is 21 greater than 13? Yeah, 21 is greater than 13. So check. 21 is greater than 13. It is correct. It works. Okay? All right, that is it for now. Go ahead and work on the pages that you have on here. I'm going to do multiplication and division tomorrow with you. Don't worry about that right now. If you feel comfortable with it, you can try it. But right now, I want you to work on the practice pages with just the addition and the subtraction, anything that works in that area. I do not have the list of them. I'll probably put it on Classroom tomorrow, but I do not have the page linked in here right now, so it won't work. All right, I hope you're making good choices and that you're having a great day, and I'll talk to you later. Bye-bye.